Hello, thank you for good welcoming here. If you do not mind, I would like to start with a simple question. Could you please raise your hand if you have ever maintained or supported an open source project that has been popular at some point of their life? Like, good, a few persons here. So I would like to apologize in front of you beforehand for causing any painful flashbacks. So if you have to go to a therapist, that's not my fault. That's because of you supporting those projects. So my name is Prykhodchenko. I work as a software engineer at Allegro's technical platform. And my job is to support not the major services, but the services that are required to manage our extensive data center infrastructure, which counts several thousands of assets, and our team used to have a problem. And today I'm going to tell you how we not fixed the problem for us completely, but we managed to make it hurt much less for us. And especially those guys who have some experience in supporting open source projects, they could probably follow these strategies. And regarding to strategies, I believe that this sort of conference is not a place to show how to use the tools or how to show how to copy and paste pieces from the documentations. We can all read that. So I'm basically going to show you our approach and our strategies in fixing the issues that I'm going to present. So let me brief you quickly with the background. And the background, as I said, is that we run an extensive infrastructure in a few data centers, and that infrastructure counts a few thousands of assets, and we needed to keep handle of that somehow, and therefore we created our in-house solution, which was Data Center Infrastructure Manager, which we called internally Ralph. And the main objective of that system was not to be used as a product somewhere, somehow, but to be used in-house. Therefore, naturally, that's the way it was maintained and developed inside of our company, not somewhere outside. We decided to concentrate from the early stages of our development not on some rendering and UX stuff, but on data modeling and on processes that we would like to process in the system. So we used heavily modified version of Django admin in order to do all that stuff and concentrate on defining models and processes. Therefore, technology-wise, we ended up using some Python for the backend and some regular front-end stuff written in HTML and JavaScript, which we didn't care too much, but we had to deal with that somehow. At some point of life of this project, we made an important decision to open source the majority of the code while keeping a really small portion of the code in our private repository, not because it had some business value, but because it was too company-specific, so we couldn't put that into public and leave users with that unusable piece of feature. And in-house, we deploy all of that on top of our Ubuntu servers as Docker containers. So we do this sort of deployments. And community, on the other hand, most of users use our prepared Debian package that they also install to Ubuntu. But there's an important but. There are so many cases and so many scenarios users run in the community. Some of them use, of course, RHEL. Some of them use CentOS. Can you hear me? Yeah. Some of them use pip install on production, and those folks come to us every once a week and complain that nothing works. So there are many scenarios that users run in their production environments. And the problem I mentioned that we used to have in our team is that community that we were giving them were often broken. We didn't have time to maintain that and to troubleshoot that because, as you can probably imagine, our team was not only supporting one system, we were supporting a range of systems inside our company that were responsible for infrastructure management. And frankly, that's a hard pill to swallow. We had absolutely no motivation to support the community because we had a bunch of work to do inside the company, yet there was another problems and issues and other support tickets or feature requests that we had to do for the community, and we had absolutely no motivation for that. And the reasons and the background for these problems was the following. So first of all, we had established two separate delivery pipelines for ourselves and for the community. And one of them was built on Travis CI, and it produced a Debian package once a week, and that was the package that users in the community used to deploy their production environments. Another pipeline was built on top of our Bamboo CI that we use internally, and it produced Docker images with our private extensions and the main source code on demand. Therefore, we ended up with two packages different sets of artifacts inside them. So whenever we were deploying one of the package to our production environment, we were never sure that other package and the other. Is it just me or the microphone is? Hope this helps. We ended up that one of the set of artifacts was never tested in production. I mean, test in production, but I mean, it was never used in production, so we could not find any corner cases. We could not even find if the deployment works properly. There was one extra thing that I mentioned. Ralph's intention was not being used as a product, was not being used for monetization somehow. The main intention was to keep handle of our infrastructure. So the support of the community was never, ever a priority for the company because the core business model of the company was different. And while open sourcing this software is debatable, yet here we are. We have an open source software that somehow gained some popularity, and we have some users to support what we can't and have no motivation to. So therefore, I thought about this solution to improve our delivery pipelines by rethinking the packaging from what we had. In order to start doing that, we wanted to redefine for ourselves what the package actually is, because from different perspectives, you can come up with different definition of a package. Let's say, is a package a file that has somewhere RPM or dep or something else in their name? Or since we have a Python application, is a package a Python wheel for us? Or maybe we could create a tarball, put makefile and call that a package, or maybe we think completely out of the box and call a Docker container image a package. Like, why not? So if you take a look at all those definitions, so every one of them has something of packagey in them, yet nothing defines of what package actually does to you. And from that perspective, we thought about the package of a distributable set of idempotent alternations, bringing desired artifacts and state changes to a target system. And while this seems to be blurry enough to not any understanding of what it is, it contains few very important words that put very important restrictions of what a package should be. And those words are distributable, idempotent, and desired, which means you should not only be able to deliver packages to a user, but you should be able to predict what's going to happen to the target system whenever the package is applied. And those packages should only bring what you want to the system, because sometimes packages do quite the opposite thing. And I would like to state it right here that containerization is just a form of packaging. Because people do crazy stuff. They think, well, the package is isolated, the container is isolated, sorry. So we can leave users with development tools, or we can produce a different result whenever the container spins off. Now, the container is just the form of packaging, so all the restrictions apply. So with that in mind, we decided to build a new delivery pipeline that actually is no different from any other delivery pipeline in terms of packaging, and it looks like an extended version of a build pipeline with a very strong emphasis on dependencies. And there are two kinds of dependencies there. One of them is build dependencies, which you are bound to have on your build hosts or some sort of build machines every time. And the only way you can manage that is to have full responsibility for those kind of dependencies. You are responsible to take care of the security patches, you are responsible to take care of any updates, it's on your side, and you have to live with that. Another kind of dependencies are runtime dependencies, and unlike the build dependencies, you have those guys on the hosts of the target systems, which means the responsibility is different between the target platforms. So under that perspective, I would like to categorize these target platforms into the two kinds. And one of them is immutable target platforms, which whenever the system spins off, you cannot, little star, change the state of the system. And little stars, that often you can, but you shouldn't. With this sort of packages, alongside of the artifacts and configuration, you have to also put all the runtime dependencies. Otherwise, nothing will work, because the users of your software will not be able, again, star shouldn't be able, to change the state of the system after it spins off. Another kind is mutable target platforms, where alongside the configuration and artifacts, you can put just the list of your dependencies, so the user can fetch them from somewhere, usually from some trusted sources, and install them after they install your package. So in this way, you get more lightweight packages, but you have to care about the external trusted sources. So keeping that in mind, we decided to take a look at most popular target platforms out there for open source projects. And we decided to create packages for Docker, for Debian-based Linux systems, and for RPM, or Red Hat-based Linux distributions. So first of all is, of course, immutable. So we had to package all our runtime requirements there. And the second two ones are mutable, so we could actually just leave the vendor repositories and the requirements that are available there. Then, before we even started to proceed with the development, we decided to take a look at the initial problem. And the root cause of this issue that I'm discussing with you today, or perhaps telling you about today, was that supporting the community was not the #1 priority. Because when we redo the packages, the core business of a company doesn't change. And I could be standing here for you and telling you that we as a team went to the business guys in our company and we defended our open source ideas, so they started taking care of it in the first place. That would be a lie. Try to do that in a corporation, right? So basically, following a DevOps philosophy means that you do not only take care about what you do, you take care about what's important. And pushing our ideas of supporting the community would be not taking care about what's important for the company. Taking care of business goals and business strategies of a company is. So instead of pushing our ideas of supporting the community and building 3 packages for Debian, Red Hat, and Docker, we decided to adapt to company business model and do whatever needed to have the single pipeline for the community and ourselves. So we have the same set of artifacts in every package we produce for the community and for ourselves. And in that way, whenever we run that in production, whenever we deploy that to production, we are sure that people can do that in their own production environments. So that solution led us to several popular and very necessary decisions that we had to make. It's like in politics. It's very hard to make unpopular decisions because you will receive tons of negative feedback. People will be screaming around with their hands in the air. But that's the decision we had to make. And the first of all was to sacrifice the idea of RPM builds. So we had some users running Ralph had, yet we had to sacrifice that just because we did not run any Red Hat-based distribution, either RHEL or CentOS or anything in our company. So we will not be able to test that without investing more time, and we don't have more time. The other unpopular solution was to sacrifice the idea to support any Debian-based distribution. We decided to concentrate and invest our time, like the tiny portion of the time that we had for Ralph et al., into supporting one distribution that we had, and that was, luckily, the distribution that the vast majority of our users had, and that was the latest LTS version of Ubuntu. So every 4 years, that's a different distribution. So it means every 4 years we support different one, yet it's the same, it's just one. And of course, we needed to run Docker somehow. And you can say, Roman, you still have 2 packages. How do you ensure both of them have the same set of artifacts and the same set of runtime dependencies in the end? You will still have the same issue that you had on the beginning. And so there is actually a solution for that. And that solution is hopefully technical. So if we take into consideration our artifacts that for a Python application and for the case of Ralph were Python source code along with some transpiled front-end stuff, we can build that, we can take a look at that, and then put that inside the Debian package. So therefore, we have a Debian package with artifacts and compiled list of runtime requirements. Those artifacts need to run successfully on the target platform. Then we somehow, some way need to guarantee that the same versions and the same runtime requirements and the same artifacts are in the Docker container. How we can do that? Easy. By discarding 99% of the code in your Docker file and replacing that by apt-get install of your Debian package that you just built. So in this way, Debian file will only have of requirements, which then will be fetched to your Docker container along with artifacts that are already passed to your deb file, and you have the same artifacts and runtime dependencies everywhere. So I'm talking about dependencies and requirements all the time. Let's take a look what a typical set of dependencies for a Python application is. And of course, every Python application needs a Python interpreter. For our case, it was CPython 3.4+. You probably need some shared libraries like database drivers, XML parsers, and so on. You will also need required Python libraries that you use in your code. The code will just not run without that being installed on your hosts. So there is a separate set of Python libraries that I would like to talk to, and that is Django, because as I mentioned, Ralph, as many other Python applications, use Django framework, and they end up being dependent on quite a few libraries from the Django ecosystem. So how do you put all of that together into a Debian package? So let's start from a simple step. You just put your artifacts, which are source code, configuration files, and some static files that you just built, into that package. Then you compile the list of requirements that those will need to run successfully, and those requirements are usually available in vendor repositories as regular Debian packages. So you just specify names and versions of packages you require. Python libraries, on their turn, are also often available in vendor repositories as regular Debian packages that gets unpacked to the Python environment. And the naming scheme is usually some sort of Python 3 dash the name of the library. Yet, you remember I separated Django libraries into a separate category. And that's because those guys are quite nasty in terms of packaging. So I don't know if you guys, how many of you actually do Django application, Django program, but every Django program, mostly, not every, most of the Django programs depend on many packages from the Django ecosystem. And unfortunately, that mix only works when you have a very specific set of versions of those dependencies installed on the target host. That means that odds of matching the requirements with the versions available in the repository are really small. So you require some versions in your Python code, but some other versions are available in the trusted vendor repositories. That means that the odds of random failures, because Python is dynamically typed and it supports duck typing, so the probability of random failures is too high and you don't want to get there. So you cannot use libraries from the trusted repositories of Debian-based distribution. In this scenario, I mean, if you do that from scratch, if you do use proper versions of your libraries from scratch, then you're fine to go with what's available in the repository. If you are like us, who try to package after the application has been completely developed, well, you most probably can't. And there are other ways to install Python packages to target systems, let's say by using Python management tools. Yet you should never ever even try to run pip or easy install or any other Python management tool, Python package management tool on your production environment, because remember the definition. Every package management system has to be idempotent, and unfortunately, Python package management is not. That's mostly because most of the libraries in Python ecosystem are not having the version of their requirements hard-coded to some strict values. Some of them, and I think most of them, do not have any version specified at all, so you never know what's being installed on your target platforms. So you can hard-code the versions for the entire dependency tree, yet you never know if one of the dependencies wouldn't require some development tools being installed on your target platform, and that breaks the definition again, because you only want to bring desired artifacts to your target platform. So never ever use pip install on your production. Are there any other options? Of course, we're engineers. Our job is to find the workarounds, right? So you could, for say, copy all the dependencies to your source tree, resulting in a huge source tree, changing all the imports in the Python code, and blah, 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 blah. So you don't want to do that. That's too much work to do. The build will take too much time. You can pre-build Python wheels or fetch Python wheels from somewhere, put them to your repository, increasing the size even more than in the first case, and then working around some scripts that run and update that somehow on your target platforms. Not a thing to do, probably, right? So another crazy idea is to package the whole virtual environment. And if there are any Debian or Ubuntu maintainers, you would start probably screaming around in your hand with your hands up like that, because that's actually the thing we did. Unlike the first two options, this one has a few great attributes that forced us to select it. And the first one is that no source code changes is required. The second one is also quite important, that you can use standard management tools in order to keep handle of that. The most important one is that you can perform gradual migration to system packages. So whenever your code is ready to use the version of a dependency that is available in your repository, you can stop installing that to a virtual environment and start using that code. You can create this sort of transparent virtual environment. So, well, how do you do that? How do you package a virtual environment inside of your Debian package? Easy. You have to create one, right? You cannot package it if it's not created. You install all your Python stuff, which means you install required packages along with the source code you have. You fix then the symlinks, because that's very important that the virtual environment is still valid on the target system, not on your build, not on your build host. And then you pack all that to a Debian package that then will deliver the environment to the target system. Seems like too much hassle to do, because you would have to do that all in a script, integrate how to dep helper probably, right? And that's basically too much work to do, and would be too hard to support, because who knows how to write dep helper scripts, right? You do it all the time with the documentation. So I have good news for you here, because a few years ago, a company called Spotify has created an extension of dep helper, which is called DH-virtualenv, and I can see some smiles there, probably Debian maintainers screaming around in their heads, because that's not how you do it by the book. That's how we did it. It's not how we did it by the book. Yet, it allows to do all the things that I've just mentioned automatically, because they implement that. It's really simple. The code base of that very small. You can go to GitHub, explore it. And I'm not going to show you how to use it completely. I'm just gonna mention two steps. First of all, you add .dh virtual env to your build dependencies, along with all the Python build dependencies that you have. And then you just invoke your dep helper with this extension enabled. Just a good note, it also provides you a great hook where you can handle all your front-end stuff and some other operations before you put the virtual into the dep package, so you don't have to create a separate script for that. Again, I believe all of us can read the documentation and go and explore it, or you can go to our source code and see how we use it. Just keep in mind, this tool is great for gradual migration of a Python application from your versions of dependencies to the versions of dependencies that are available in your trusted repositories. So to summarize the Debian packaging, so you should make use of matching requirements and the list of them in a trusted repository. So if from the beginning you can see that your application is able to run on the top of the requirements available in the repository of the system you are packaging for, use that. Do not put that into a virtual environment. And if you see that some of the requirements have versions that are unavailable in the repositories, put them into virtual env, use dhvirtualenv to pack that, and then find time, somehow, find time to gradually migrate the code from the versions of the requirements you have in your virtual environment to the versions that are available in the repositories. It may not be possible every time because the repository are limited in their packages, and you may use package that is not available in trusted repository, and vendors are unlikely to put anything there unless they have a solid business case to do so. So you may end up with having several requirements in your virtual env forever. Yet that's better than having nothing and being unable to package at all. So for the Docker, that's it, and for Debian, that's it, and for the Docker. So as I mentioned, we recommend you to not build the Docker from scratch, but just use what you already built for the deb package and install that to a Docker container. So for that reason, you would have to use the same base system as you require for the Debian package or for other package that you select. So for our case, that was the latest LTS version of Ubuntu. It's a big image, so probably you would try to select, normally you would try to select smaller images. We had no choice at this time but to select the latest LTS of Ubuntu, yet we managed to put, with this help of the deb package, we managed to put the same artifacts and the same version requirements to the container image. And then we tried to figure out what extra layer of complexity comes up with Docker, because when you install a package to a target system like that, Debian package, you just can't change anything. You can go to settings, you can serve static files, you can do it from scratch. But for Docker, it's all isolated. And we could not also expect that users would just run manually Docker run on their production environments. They are likely to run some sort of container orchestrators. It could be Kubernetes, could be something very simple like we have in our production deployment of RAL, where we use just Docker Compose. And users have to be able to run containers there, not manually with Docker run. So they're also likely to perform some sort of operations there. So if, let's say, you need to run database migrations, or you need to run some sort of other management operations, you do not want to force users to go inside the container. So you can do that in a development environment, but going inside the container on a production is not an option. I mean, you still can do that, you shouldn't. And talking about that, we need to address these issues. And the first of all is startup and running operations. Sorry. First of all, we wanted to notice that you have to create a single entry point script for your Docker container. That means that you do not expose the file system underneath. You just run one single script that acts as a facade to all of the system tools and all of the services that you have there. And whenever you spin off the container, it runs either a service by default or some sort of management operation that you have there. So in this way, users will not have to go inside the container to run database migrations, for instance. Then configuration. How do you handle configuration? Your application is most likely to have some configuration requirements. And the first option to alleviate the issue of configuration is to use sane defaults. Yet, alongside those sane defaults, you will always have to have some options that have to be configured on your target platforms. And for that options, there is a general approach that is widely used for good packaged container images available publicly. And that's to specify several environment variables that will be read by the startup script when the container is spinning off, and then mapped to the configuration. In this way, users who only want to set those essential options will be able to do that with Docker environment variables. And they will not have to go into container, but the container, when it spins off, will already have the required configuration in place. So those in need of supplying additional extra options will have to map the configuration file to the container. So for that, there is a compromise. So you expose the internal structure of the container, so users have to know which file to mount as a volume, yet they will be able to configure the system advancedly. Static files. For a Debian package, static files are in user share something, probably. For the container, they're in the same place, but inside the container. And you have to be able to serve them somehow. Some people suggest you install several services into the container. That's not how containers are designed. Containers should be on the one thing. In that case, it's your application. And we suggest to build a separate container image for static files. So users can put that into their orchestrator, and that container image more likely to be built on top of Nginx or any other very, very lightweight HTTP server, and its only purpose will be to serve those static files. Users then will be able to reroute requests to your main container or to this static files container based on their infrastructure, and that's no way different of rerouting requests for the service and for the static files when you install the service from the Debian package. Yeah, that's what I do. So to summarize, for building successful Docker images, use single entry point in order to isolate users from the structure of your container. Put all the essential configuration options to your environment variables that are mapped to the configuration files, and let users map advanced configuration as a volume. Static files are better served while they are available in separate container, and when you do that, when you build those two containers, always publish at the same time. So if you see that you build one container, wait for the second one to be built, and then put them all to Docker Hub or to Artifactor or to any other container image servers that you have. In conclusion, I would like to summarize the whole strategy and the whole idea of how to make it heartless when you are maintaining a project for some sort of community. But the company goal is not that project for the community. The company goal is something else. In that case, if you want to still have your community members happy up to some extent, do not try to cover every corner case. You will not have time for that, never. Support only opinionated scenarios that are based on your in-house usage, so you are able to test it yourself in your production environment. You're able to see how it actually works without leaving users with something you never run yourselves. Do not wait, never wait until everything is perfect before you give things to user. Give them something in the beginning and improve things gradually. In this sort of scenario, you will never have time to improve all the things and then give them to users. You will always have something that needs to be improved. Give them something, and then keep on improving that when you have time and resources. And you should never, ever be afraid of farewell the users that are corner cased. Because, again, if you have limited human power or limited workforce, you will be either satisfying the request of those two guys who run pip install, and you'll forget and you will not have time to support the 99% of your users that actually run and that could be satisfied with your opinionated scenario. So select wisely between the majority and those two guys who need the most of support but run the weirdest scenarios possible. And the last but the most important one is that you could make any decisions in your project. We've done several. We decided to open source it, we decided to use Django admin, and they bite us into our arse. Sorry for this word, somehow. Yet, doesn't matter which decision you make in the project unless you cannot reverse them. If they're irreversible, any other arguments should not be used. Do not make irreversible decisions in your project. And on that, I would like to thank you all for your attention, and all your questions are welcome.